Okay, I think we can start. The first talk of this afternoon is about communication protocol specification in Python. It's done by Frederick, which surname I don't remember. Difficult to pronounce.
Oh, okay. Oh, this was really loud.
Yeah.
Yeah. My name is Frederick Haard, which is not that hard to pronounce, is it? And I'm here to talk about communication protocol specifications in Python, as you can see. This means that I'll be talking about two distinct things, really. I'll be talking about code as specification, and I will be talking about how to make a Python syntax look like its specification syntax, so how to make it more declarative, really. But more than that, it is a case study and a lessons learned, so I will do my best to beat the confirmation bias and show you all of the mistakes I've made instead of just showcasing success. I will start out by lining out the problem domain. And the domain is a company called Visual Units, a smallish company doing support systems for logistics providers. The system we're interested in is a fleet management solution. So there are those, the hardware you can see there is a mobile terminal. GPR is GPS on a J2ME stack. And they report their positions in real time to twisted Python server. And then that data gets stored and done things with. Displayed to the customers on maps like this and so on. And what I will be discussing is the communication between the mobile terminals or black boxes and the server, because that's where the problem was. So what is the problem? Well, the problem is that when you do this and you do the embedded terminals, the first thing you run into is you want all of the information to be able to troubleshoot, and you don't want to send more data than absolutely necessary, because even though free mobile internet in your phone is plentiful, mobile internet for telematic solutions is still really expensive, especially since this is a fleet management systems and the vehicles just won't stay in Sweden. They insist on going abroad where it's even more expensive. So we have in the communications protocol really 2 or 3 different concerns to take into account. Since we are doing real-time or human real-time, which is it should feel like real-time positioning, we can't have a communications lag of more than a few seconds at most. We also don't want to send too much data, or too many bytes really, but we want to send as much data as we possibly can in those few bytes. And we also have some security concerns so that people can't just inject data into our stack, of course. So we have a proprietary protocol which is tightly packed. We used to do a bit shifting to pack it even tighter, but we've moved away from that a bit because of making the stuff readable and because it's not as expensive as it used to be. But there are some problems with doing proprietary protocols. You need to keep the documentation up to date. You need to keep specifications available for others to use so that they can jack in on your stack with their black boxes instead. And you need to be able to keep supporting several versions of the protocols, because when you roll out a new version of the protocol, when you roll out new functionality, you'd like to be able to do a stealth launch, start testing against your production machines before releasing it to the customers. You want to be able to support several versions of the protocol. And all of this was handled manually to begin with, which is to say that each new protocol version was implemented by hand, and then the black boxes actually just connected to next port in range. So if you started on port 10,000, then the next protocol version would get 10,001, 10,002, and so on, which honestly does work for a long time, but the overhead of maintaining those versions of protocols and trying to keep documentation available, especially when documentation is only occasionally used, and then you realize that curses, we haven't updated our documentation again. So we looked at existing solutions like Google protocol buffers or different ASN.1 specifications, if anyone's familiar with those. And we found out two things. Size does matter. And it's not that they don't pack the data tightly enough. It's that you have to use a 200 kilobyte jar file to be able to use them. And that's a lot of space that we can use for better things in an embedded system. And the other thing is that a lot of those do funky stuff which just won't run on J2ME. It's, I mean, you're really limited, and you don't have doubles. And for some reason, some of those use doubles, and it will just break. So that road seemed close to us. We tried some more or less obscure. It didn't work. And while thinking about this and trying to set up the requirements, I actually accidentally wrote down an implementation or a requirement specification for what we wanted. This is it. You can all read this, yes? I actually still have this paper, but I failed to bring it, which was a big mistake. I'll transcribe it for you, for those of you who couldn't read it. This was my original sketch of what I would like out of a protocol specification. I would be able to set a couple of tokens that my messages can consist of, and then compose messages and create a protocol which can then parse those messages. At this time I was not concerned at all about how we actually do transmission and stuff like that, because we do transmission in different ways. This is about taking data, converting it into byte arrays, and taking byte arrays and converting them into data. And I also wanted to, which was not on the sketch, be able to generate documentation by looking at the resulting protocol object and generate Java source code that I could just use in the embedded terminals. And this has been, I have to say, a really, really useful implementation specification or requirement specification. I would advise anyone to keep their napkin sketches, because it lets you do a sanity check. Am I still on track? Is this still the vision I had? And we'll see how that becomes useful. So the first version of that protocol spec actually looked like this instead. And this was a version that made it until, well, limited production use or testing to show that it works. The general idea is that messages are assigned a type byte. This is this kind of message. Then tokens are created by telling them what they have, what the name is, and the Java type, and the C type's type. I will not talk about how we actually parsed strings, but the simple case is that Java, it's really easy to send UTF strings. It will just prepend the length of the string and then the data. So we just parse that data. So they are a bit more complicated to parse than the other tokens. Then we create messages, which we give a name. We tell them what type byte to use, and then we just list the tokens they are supposed to parse. So we create a new protocol by saying I want a protocol. It should call itself version this, and then list the messages it should be able to parse. This works. The way you use it is you import it, and then you just ask it to parse this data I have. And to create the Java source, you get the protocol, and you ask it to create Java source. And it gives you a string back, which you write now. This worked. The generated Java is the very simplest possible. I've actually cut out the try-catch stuff here. But otherwise it just creates a byte array in the very verbose Java way. But which does work and is sufficiently efficient. And as I said, I started out doing this in the same way as we had previously done with using types smaller than 1 byte, but I decided it just wasn't worth the extra effort, actually. So this is the Java source generated, and when we get that data, the protocol has created a mapping of the type byte to message instances. The message itself will take that data and use the tokens to get the interesting data out and stick it into dict, which it will return, and then the server will do stuff with it. In reality, simple fixed with tokens will actually be merged, so we don't do one C-types unpack for every single field. However, when we have string fields, we have to do them manually because we have to first unpack the length and then unpack the actual string. And this is more or less the same in the current version, actually, at least the general flow of it. There have been some other optimizations as well, but no big changes. But if we do a goal check, this was what I wanted, and this was what I had. It's looking at it now, I don't really think it was that bad, but I felt it was really, really bad at the time. And the things that still itch me with the implementation like this, it's that we have a lot of duplication. We have message is token message, timestamp token timestamp. We have message log equals message log log, and so on. And it just didn't feel right. I felt that I should be able to do this in a better way, in a way that looked less like code and more like specification, perhaps. So the next version should be better, right? I've done my prototype, threw it away, and now I'm going to do it right. I'll give you a hint that the next listing is on 2 slides instead of 1. So to start out, I did something that was kind of good. I actually extracted so I didn't have to specify the types every time. So I did a shorthand typedef by mapping the types. And then the token specification looks about the same, but I'm just sticking strings in there, which I would argue is actually bad, but that's the way it turned out. And then I also created markers, and I no longer had to assign anything anywhere. I just created the messages, so there was a bit less duplication. And I figured that now that I'm doing the rewrite, I'll also introduce flow control into the or syntax into the protocol. So I created an implementation where you could say, well, this is the first message that should arrive, and then these messages can arrive, and these messages can arrive, and so on. And if we're at the end of the protocol, we just keep on taking the same kind of messages. So you could say that the protocol could handle that you had to authenticate before you could send any other messages. Otherwise, it looks more or less like it did before, except for that if you try to parse messages that are out of sequence, it will blow up on you. How many here grok metaclasses? That's a fair amount, and some who do. How many here know about metaclasses? Yeah. I'll show you how not to use metaclasses. The thing is that when I wrote this, I read a really interesting blog post about metaclasses. And I was blown away. I mean, this is magic. I can do anything with metaclasses. Yeah. The message class and the other classes that weren't assigned anywhere, since they were classes or instantiations, used a meta class that actually just wrapped the dunder init function in another new init, which registered that instance in a module level mapping. And I will say that there are easier ways of doing this, like a superclass or a decorator, or just using that mapping. And you know, this is the danger of interesting technology. And if we're normally scared about the man with the hammer, with a hammer, I'd say that this is an example of a kid with a nail gun. It's like, I can use this. And I've seen other people do similar things, so I would advise you, when you find new interesting technology, don't try it out in production code, please. Try it out and see if you really do understand it. And there were some other problems here, that the flow control thing was handled by having checking if we were allowed to receive this kind of message. And then the flow just iterated over the sequence until it got it to the end, and then it kept on allowing the last set of messages. And the problem here is that this is kind of a semi-generic solution to solve our very, very simple problem that strangers should not be able to send us data, because that's the only rule there was in this syntax. You have to be logged in to send data. And this introduced other problems. I could no longer use this to parse data which had taken the round trip over disk because of some kind of failure or another, unless I injected authentication data before. And I paid all of this price just to move the authentication into the protocol, which, as everybody knows, is you shouldn't handle authentication yourself if you can possibly use somebody else's established solution to it. Nowadays we do this at the handshake level if we send it over the wire, and this was just generally a bad idea. You can say that this version was a collection of bad ideas, really. But it's a learning experience, right? So again, this is where I really realized that having that piece of paper, which was still attached to the original notepad by then, was a really good idea. Because when I flipped it through and looked at the original sketch, this doesn't really look alike, does it? It's become horribly verbose to do something really, really simple. Remember that the only thing we want to do is pack data into byte arrays and be able to unpack them. And we've created, or I have created, a monster. And we've also, or I had also actually introduced new weaknesses in the protocol. One goal that was not shown on the specification, if you call it that, was that we wanted simpler handling of different protocol versions. This actually broke having protocol versions that had the same token types, because we had one global mapping of types. So if two protocol versions actually declared the same token type, then the second one would just overwrite, or it would throw when I set in a guard so that it couldn't overwrite types. But then I wanted to monkey patch a protocol version, and then, yeah. I'll say in my defense that this never ever saw production use. I realized before that this was actually a bad idea. So the implementation is complicated. It's definitely hard to explain. It can't handle changes easily, and I mean, some of this would be salvageable, but I figured that it's just not worth the effort of trying to make something good out of this heap of badness, so to speak. So the next 2 or 3 versions were kind of more of a blur and ended up in one version that went into production, which was the previous version. This was the version used until this spring, when I did a previous version of this talk and did a blog post and got some good ideas from the comments after the talk and the blog post. And it looks like this instead. We create types still without any kind of assignment, and then we create messages where we have a doc string to have some more information when we generate the documentation, since the documentation otherwise gets hard to read if you have no context. Removed most of the duplication, and it looks kind of close to the original one. However, I got some suggestions both after the presentation I held and on especially Reddit. And one of the suggestions was you should do this like Django does it. You should invert the declaration, and you should do it with a class. So this was the example I got. You should do it like this. I thought this was a bad idea, not only because it has the dangerous word meta class in it, but also because it actually introduces nesting into the specification. And the whole idea was that one file that is at least readable and understandable, this is what the protocol looks like, even if you don't know lots of Python, and it should be easily parsable. I shouldn't have to think while reading it. Every indentation is something I have to abstract away in my mind. So I didn't really like the fact that I would have to nest it, but I did like the idea of changing the whole initialization of types, because here we have the little T method to create the types, which is kind of iffy. So the idea was, some of the idea I thought was sound, so I actually did that, and instead I said that well, I have all those types, I'll just call the new type to create, or I have a type def really, which creates the type. So I say I want 64-bit integer, so I say I64 timestamp. And I think this looks much nicer. I have done some blasphemy to make this work. But I've also added some stuff that wasn't there before. Of course, the declaration is shorter and I believe cleaner. I mean, I'm not afraid of typing on the keyboard, but I want it to parse in my brain as fast as possible when I read it afterwards. Also added in this version is that we actually have protocol version support integral, and I'll show you how we did that. Otherwise, it's just the same. We just load the protocols, and then there's a mapping between protocol versions and protocol instances. But this part, there's still some kind of magic going on here, clearly. So what I do is that I hack the stack, or really don't. I use the stack to insert names in the namespace. The type defs themselves are just created by calling, using the specification of the type and calling this method. This will generate a type function that injects the given name into the calling namespace using and having the value of a token made out of that with that name and the type given. So I have been flamed for this, but I actually think that this is a really, really simple implementation. And you may disagree and explain to me how it's always blasphemy to use stuff like this. But the thing is that the alternative solutions took 10 minutes to explain. And this is a type def. It injects the name of the type you're calling back into the calling namespace. If you don't understand that, then you have no idea what the stack is, and well, you're kind of out of your depth, perhaps. But you don't have to understand the implementation if you don't want to. But it's also very, very simple. There is almost more documentation here than there is actual code. So this makes sure that this syntax actually works. That's the only thing that it does. It simplifies the type defs. And then we have the imports. The imports are done by actually having one place to dump all new or old or all the protocol definitions. And when we ask for protocols, it lists all the files that match protocol version.py and loads them, or attempts to load them. I've removed error checking and such things from this one. If it can load them, it will insert them into a dict. And you can see that there are some warts left to remove, like why is, let's see, why is the version a float instead of a string? It has always been that way and it has never been removed. But it works. And in the real solution we also have both lazy loading, so that the protocol isn't actually loaded until somebody asks for it. And we can turn on a flag so that protocols are always reloaded every time a new client connects, which is really handy when doing end-to-end testing of new protocols. But that's just some sugaring on top, really. So this is what it looks like. It takes a path, and it has this regular expression. Regular expressions are nice, right? We like them. And then it just lists everything on that path, checks if it looks like a protocol. If it does, it will use find module, using the file name and stripping the extension from that path. I didn't know about load source when I wrote this. It's like 10 rows below load module in the documentation, which shows I was probably in a hurry when I did this. But if you're not in a hurry, you're not writing code. If there's not a deadline, why would you? And then it just loads the module. So that's all of the magic behind it, really. It's this one and this one. And then generating the Java source is just, I mean, that's just string templating. That's easy. So the goal check. This was the original specification. And this is what we got instead. And I would say that we're pretty close to where we were, and we have added some things that weren't there before, like the documentation string. This looks different, but I have found no way of making it look that way without nesting. So this version I'm actually pretty satisfied with. Since I made this last change, I haven't made any real changes to the protocol implementation. And it was a year before that I made any changes. Although we have released at least 10 different versions of the protocol since then, because we do a lot of prototyping. When you're a small company in a fast-moving market, you have to kind of try to keep ahead of the game. You need to restart your computer. Whoa, I hope I can finish this. I can't. What just happened? As anybody is a Mac wizard? Yeah, why does it do this to me? I have never ever seen this. This is like a blue screen of death for Mac. It tells me in 5 languages I have to restart my computer. Yeah.
Yeah, it's really so much user-friendly.
Yeah, it's just locked. So I'll just finish this without the slides. It's okay. There were some things I haven't spoken about. We did try to do what they call it, literate programming. to get the documentation of the protocol intermingled with the code rather than just extracted from the live protocol object. And we did that by using, I used 2 or 3 different packages, and we had RST format documentation, since it's Python. And we could generate pretty documentation. The problem was that the code actually got less readable for a programmer, and the protocol specifications are, after all, read and written by programmers. So the fact was that the implementation without the attempt of introducing RST into it was a lot better documentation for any Python programmer than the literate attempt was. So we kind of ditched that one. Let me see if I remember what I wanted to say more. I had a beautiful example of our beautiful documentation, which is a table telling me this is the when you want to send a message like this is the type byte, and then you have the fields, the width of the fields, because that's every protocol specification ever, and I have written enterprise grade protocol specifications, have loads and loads of text, and then in the end you have this part that a program actually cares about, which is how do the messages look, and what are the magic bytes I have to set to make them parse. So that's actually all we generate. The docstring you saw in the specification is used as a header, and then we just list the fields that are used. So I might be missing some really important point now, but I think I'll wrap up anyway. Yeah. I got the idea to talk about this once when I was irritated over the fact that all videos on pyvideo.org talked about success stories. And I mean, for us, this is a success story, but it wasn't a success all the way. It is worth trying out to do stuff, even when you fail. Even when you do things you will be ashamed of half a year later. It's totally worth doing, because if you didn't do them, you wouldn't know enough to be ashamed of them half a year later, probably. And it's also worth doing custom implementations and doing them correctly. I mean, what we've done is basically a small framework for protocol specifications. But even though I absolutely loathe the great amount of frameworks, they aren't all bad, especially not if you're writing them yourself. Because what we have is, we have a solution that's perfectly tailored for our needs. I can, if I find that I want to have new data, or there's a new API for the next version of the pick code for our terminals, once I got a hold of that API, it takes me less than an hour. If the data I want is easy to fetch, then that's still the hard part, because updating the protocol and making sure that the data ends up in our database it's no work at all. We update the database and we update the protocol, and we have a solution where any data that's sent that we haven't actually told it where to end up ends up in the bucket, so that we can actually add and test out data. We probably should use and will use a document database instead, so we can just keep adding and removing data, of course. But the fact is that most people cannot roll out a new protocol in a matter of hours. Most enterprise companies can't roll out it in weeks, because they need to have implementation specification of 20 pages, and then there needs to be a protocol specification of 20 pages, and then you have to write it and realize that the specification was wrong and rewrite it, and then you forgot to update the protocol specification, so that when somebody reads that protocol specification, it will still be wrong. And that happens. How many here have never read a protocol specification that was wrong and does some work with transmitting data? There are no hands up. So the glorious part of generating or using code as specification is that your specification won't be wrong. I mean, the actual behavior of the system can of course be wrong, but you do know that the specification and the behavior of the system is the same, because it's the same code. We actually use the specification to parse the data. And I do believe that more people should do that instead of using ASN.1 or other stuff, because it's dead simple to do. You can look at, there's on my Bitbucket account, which you can't see here. There's an example implementation of this. It's a bit watered down since I've had to rip it out of our code, but it gives the basic idea of what we have done. And I recently updated it with a new typedef implementation. And really, I mean, most of us are programmers. So instead of just taking somebody else's solution, which is just almost okay, it's not that hard to, program a solution that's just perfect for you. Yeah, and I'll end a bit early since I get kind of lost without my slides and notes. Yeah, but that will take more time probably. So, questions?
So sometimes real-life protocols are a bit more complex than you described. So it might be some block which repeats several times, includes other more like dependent blocks inside. So did you have anything similar, and how you solve this?
Yeah, well, the beginning thought of having this flow control was, of course, introducing a syntax and what is allowed and so on. We cut that out because, not because it's impossible to do, but because there was actually no need for us to have it. I would say that most protocols actually can be abstracted down to message passing, at least most protocols that are not human-to-human protocols in one way or another. I've done, of course there will be exceptions that I haven't found out about yet, but I've done a fair amount of machine-to-machine work, and I have never seen that you would have to have the problem comes up when you have a protocol where you need to specify dialogue, of course, because then you need to maybe you need to specify how to do that flow. In an implementation like this, you would ignore the fact that you have to have a logic of what message to send now and so on. This is what we do. We need to have authenticated before you can do anything else. We have some messages that updates the tells the server where the terminal thinks it is in its level of execution, which may be stranger than you think, and so on, which actually has to be generated and received in a specific order, but that's actually handled by the next layer that does not care about how the data is represented over the wire. So this protocol specification is actually only targeting the problem of getting stuff over the wire fast and reliably, or over the disk or over whatever transmission medium you have. And if you wanted dialogue support in your protocol, you would have to solve that either within this or on top of it. So that wasn't really an answer. It was an answer that, no, I don't have an answer. Anyone else? Someone on the phone has an answer?
Hi. One question. In front of your initial specification, I think if I had written that, I would have two ideas. One is, okay, let's write Python code that implements that specification as closely as possible, or let's write a parser for reading that kind of specification in Python and, do the other way around. Why did you choose the first, just because it was more good-looking, or you think there is some advantage?
There are both, I'd say. One is from the ideological standpoint that you shouldn't introduce complexity, and a parser would be a DSL which needed to be validated and so on. So I believe that would have it would have ended up being a more complex system. I would have re-implemented ASN.1 instead, in which case I might just as well have implemented a new parser for ASN.1 to generate Java source from ASN.1, where there might be such a thing that I didn't find. The other part, well, that was the real reason. The other reason is that it removes me a little bit more, or it puts extra steps between the specification and the actual parsing, which may or may not actually increase the risk of having discrepancies somewhere because of a bug somewhere. Right now we have very, very little code to handle this, and I can be reasonably sure that I've caught the bugs and not introduced new ones when I changed it. But I do feel that with the parser and so on, I might have edge cases that I haven't thought of. I might introduce subtle bugs that won't be as easy to find as if now when the actual specification is executed. I think there's less risk of having bugs if you have less code actually. So that's the other explanation. Any more questions?
I was wondering, in the code that you have showed before about the type that you inject in the local globals, you are doing that because you want to have a class which has that type at runtime. You want to create a class.
Yeah, that's not actually creating a class. It's just creating another function. It's a function that creates a function that creates a function actually. But the thing I want is I didn't want to have to both specify the name of what I wanted to of the token I have and assign it to that same name. So it's about aesthetics, I suppose. I thought it looked ugly to have IMEI equals IMEI int64. Instead, I just say int64 EMEI. So I just specify the minimum amount I have to. And of course, you could do this by doing nesting in some form or another, so that you actually attach the name to something instead. Which was the suggestion of making it look like Django or what I did from the beginning. I actually do think that when using it, the current version looks nicer when generating the tokens. I would like to, without doing this kind of magic, be able to write whatever name I want equals the type I want. Because I think that, and that was the original sketch and what I really would like. But I haven't found a way that satisfies my other requirements that does that.
I was thinking about using type with 3 arguments, because you can create a synthetic class. So you specify the name, the basis, so there you may specify the type of that function and the attributes of that. But you will probably repeat the same name twice.
Yeah, so you'll end up in the same, and I did play around a bit with type and so on, but I didn't solve that problem. I haven't yet solved that problem in a nicer way than it looks today. I might get an idea from one of you later. I don't know. Is another question?
Just as you mentioned, have an idea from our audience. So did you consider using YAML as this specification language? To me it looks much less magic and would do the same probably. It would generate the parser from YAML description.
Yeah, it would have the same benefits and drawbacks as writing your own DSL, really, that you wouldn't actually execute the specification. You would execute a parsed representation of the specification. Of course, you would gain that you actually had you got the parser for free, but it could be done. It could be easily replaced, but it would actually require more scaffolding to translate the object graph from the parsed YAML into the actual protocol implementation than the current one does, since the current version doesn't actually go anywhere else than from what's written into the implementation. So it would add more scaffolding, and I don't see that I'd gain that much really. I mean, YAML is a nice format, and or I could use JSON or anything, but none of them are written as a specification language for protocols from the beginning, so they have much of the same limitations in their syntax. And of course I can hack the syntax of Python, but I can't hack the syntax of YAML without hacking the parser, and then I'm back at hacking stuff again.
Have you considered adding as properties to the protocol specification also the fact that the protocol that you're using is context-free or context-sensitive, as that could have, you know, some security implications, and already in the specification phase, if you were already to reason and think if it fits under one category or the other, you could avoid, you know, a lot of security problems, like integrating the work that Meredith Patterson and people from Langsec did on, you know, formally defining security of protocols, and having that inside of a specification language would be something useful.
Yeah, since we, I have, during that atrocious second version, I did speculate about that would be the way to go. And just like adding syntax, it's in the end this was something that we haven't really needed, because we control or at least are aware of everybody who's sending data and have the certificates to be able to send us data. We have one level of access, which is you have access to write your data or you don't have access to write your data. Since a unit can only ever write data identified by that unit or that terminal, we don't really have that problem. And much like adding syntax, you'd either have to solve it in an elegant way inside, or you'd have to do it outside of the actual packing and unpacking of data. So again, the short answer is no, not really. Thought about it, didn't do any work on it.
You mentioned Twisted.
Yeah.
For that acquisition. How does your protocol specification relates to Twisted protocol class?
We use Twisted mostly as an application server, really. We use a TAC file or whatever the modern equivalent is. I don't remember which is the old and new version. To launch it, and we have a single protocol instance that takes care of incoming TCP connections, and in that protocol implementation we handle authentication and determining what protocol implementation that client wants to speak to, and that's also where we choose whether to do whether to load all the protocols prematurely or load them lazily or just reload them every time somebody connects. So that's where we do have stuff that's not pure unpacking and packing is in the protocol implementation. So the Twisted protocol implementation actually does the handshaking part, and then it reads messages and passes them to the protocol implementation, and takes the resulting and passes them to the backend implementation. So we don't actually use a lot of Twisted. We use it just to be fast and convenient way of managing the application. Are there any other questions? No? Well, thank you.